There can be dozens or even hundreds of different options to choose from for each underlying security. So how does one choose? In order to answer that question, it's best to understand how option pricing works. An option's price is the sum of two components, its intrinsic value and its extrinsic value, which is also referred to as time value. Intrinsic value is simply the dollar amount that the option is in the money, or ITM, or what it would be worth at expiration when time value is zero. Out of the money, OTM, options have no intrinsic value. So let's say you have a call option with a strike price of $50. If the underlying stock is currently trading at $55, the option would be $5 in the money. That's its intrinsic value. However, when you look up the option, you notice it's currently priced at $7. This additional $2 is its extrinsic value. Extrinsic value is made up of two components as well, implied volatility and days to expiration, or DTE. Volatility is influenced by many factors, including market uncertainty and significant company news, such as an upcoming earnings announcement, just to name a couple. And days to expiration, well, that one's fairly straightforward. The longer the DTE, the higher the time value, as there is more time for the option price to change. However, it's important to understand that time value decreases exponentially as the option's expiration date draws closer. So, if you hold an option position and its underlying stock hasn't changed in value, you'll notice the option's value dropping because time value is eroding. Out-of-the-money options are much more sensitive to decreasing time value than in-the-money options. Taken together, intrinsic and extrinsic value make up an option's price. Unfortunately, calculating it isn't a cakewalk. It can be estimated using a complicated formula called the Black-Scholes model, which is beyond the scope of this introductory lesson. But let's look at another option pricing example using a chart to see how this relationship works in broad strokes. Along the x-axis, we have the option's days to expiration, and along the y-axis, the option's total value. Let's say we have a call option with a strike price of $90, and the underlying stock is currently trading at $100 per share. The first bar on the left shows the option's intrinsic value of $10, the difference between the stock's current price and the strike price, along with its extrinsic value, which is made up of its 40 days to expiration and its volatility of 30%. Now let's say the stock price rises slightly to $102 over the next 10 days, and its volatility remains the same. You can see on the next bar over on the chart that the option's intrinsic value rose slightly to $12. However, the extrinsic value is lower because we now have 30 days to expiration and volatility remained the same. Notice that the total value of the option did not change. This is because the increase in intrinsic value was offset by the decrease in extrinsic value. Now let's say the stock slips to $100 per share over the following 15 days, and its volatility climbs to 45%. On the third bar in our chart, the option's intrinsic value is back down to $10, and its extrinsic value is unchanged, with the decrease in days to expiration offset by the higher volatility on major company news. Yet, the total value of the option has gone down. Now let's look at the last bar in our chart. The stock is up to $105 following the news announcement, so the option's intrinsic value pops to $15. However, volatility is now down to 20% and there are only 5 days to expiration. See how the total value of the option is less than what we started with, despite the stock being up $5? The increase in intrinsic value was not enough to make up for the loss of time and the drop in volatility. The lesson here? An option trade may not be profitable even if the underlying moves in a trader's favor. A common real-life example of this occurs around earnings announcements. Volatility is typically higher than average prior to the announcement, which can inflate option premiums. Then after the announcement is made, volatility typically drops back down to normal levels. This is called a volatility crush. Now what we've walked through here is a very simple example of how an option's price can fluctuate based on changes to the underlying price, volatility, and time. So, how can you grasp the impact that intrinsic and extrinsic values have on an option's price? For that, let's look at an option chain. The deeper in the money we go for both calls and puts, the higher their intrinsic value becomes. And the more days there are to expiration, the greater the extrinsic value. All things being equal, An option that expires in 30 days has a lower premium than an option that expires in 120 days when they both have the same strike price and underlying stock. And that's intrinsic and extrinsic value in a nutshell. Understanding these components can help traders make educated guesses as to how an option's price may behave. This is especially helpful when selecting strike prices and expiration dates for new option trades, as you'll soon discover in our next lesson.